This is the first JPOMO Final Stage Junior Division, Part 1, Problem 9, and the problem reads as follows. Pelican has a deck of 16 cards numbered from 1 to 16, and the cards are stacked in ascending order of their number with 1 on top. He attempts to shuffle the deck as follows. Firstly, he separates the deck into two smaller decks, one containing the top 8 cards and the other containing the bottom 8 cards. And secondly, he then randomly chooses one deck from the two decks, then takes the top card from that deck. He repeats this process, putting the card that he chooses each time on top of the previous card he chose until he forms a full deck of 16 cards. He does this process exactly twice. The probability that card 1 is somewhere above card 2 in the resulting deck is equal to m over n, where m and n are relatively prime positive integers. Find m plus n. First, let's try an example of what the shuffling would look like. The first step is to separate the deck into two smaller decks, each one containing half the cards, and initially that would look like something like this. So 1 to 8 is on the first half and 9 to 16 on the second. Then, Pelican would repeatedly choose a random deck and pick the top card from there. So if I try that, for example, I'll take this one, I'll put 1 here because it's the card on top. Then let's say I choose that one again. Then I'll take 2. Then here, I'll take 9. And then I'll take the first one again. And that's 3. And then I'll take the second one. So that's 10, and so on. So notice that the cards from the same half appear in ascending order. So there's 1, 2, and 3 here. And then 9, 10, and so on. So, however, this time the card number 1 appears at the bottom. With this logic, if we do this process again, then the number 1 would appear above number 2, but under some conditions. Basically, we need 1 and 2 to be in the same half or uh, in different halves, but with 1 chosen before 2. Okay, so that will be our two cases. So if we have these two cases, then the answer, or m over n, would be case 1, since that would already guarantee that that 1 is above 2, and 1/2 of case 2, since we need card 1 to be above card 2. So by symmetry, there would be a 1/2 chance that card 1 would be chosen before card 2. So all we need to do is to evaluate the probability for each case. Note that the total number of ways to choose the position of cards 1 and 2 is 16 choose 2. And we can actually evaluate that right now. 16 choose 2 is 16 times 15 over 2. So 15 times 16 over 2. That is 120. Okay. And let's try computing case 1. So 1 and 2 are in the same half after one iteration. So we already have our denominator, which is 120. All we need is our numerator. Since we want them to be in the same half, we need to basically choose 2 slots out of the 8 slots in that 1/2. So that would be 8 choose 2. However, there are 2 halves, and we don't really care about which half has those 2 cards. So we multiply this by 2. And so we get that this is 2 times 8 times 7 over 2, which is 56. And so the probability of this would be 56 over 120, which is 7 over 15. And case 2 is just the complement or the opposite of case 1. So the probability of this would be 1 minus 7 over 15 equals 8 over 15. And we can lastly substitute this here to get our answer, 7 over 15 plus 1/2 of 8 over 15. and we would get our answer is 11 over 15. And so m plus n equals 11 plus 15 or 26.